here's the how we're gonna write down the complex number in general. So this looks like A plus BI. Or you can write down, which is the same thing, A plus IB, where A, B are numbers, 5, 6, 7 are just numbers. For example, if you have, let's say, numbers 5 plus 6i. So we can call this one complex number. Why? Because it contains two parts. This is the real part. And here's this one is the imaginary part. So we have two parts, real parts and imaginary parts. Write down these because they're gonna ask you exactly the same thing on group sign. And there's a real number and there is pure imaginary number. So this is the real part and this is the imaginary part. Here's the thing. So now, A plus BI. A not equal to the 0 and B not equal to the 0. Now this is complex number. That means A is not 0 and B is not 0. So now we have the complex number. Another note, if A plus BI, if A equal 0 and B not equal 0, that means A equals 0, so that means we're going to cancel the A. Now it's going to be the pure imaginary part. That means just the imaginary part. So we have just imaginary part. They call it pure imaginary part. The third note, A plus BI. Now A not equal 0, B equals 0. So B equals 0, that means BI, the whole part here is 0. So we just have the real part. That's what they're going to ask you on the first thing on group sign. If you check the first examples, you just have to know the complex number contains two parts, A plus BI. A, B are numbers, and I, which means this is the imaginary part. Here's an example, or sometimes with different sign. If you have 5 minus 6i. So it doesn't matter because the imaginary part is the negative and the real part is positive. A plus BI, A not equal 0, B not equal 0, which is this is the complex number. You can write down here complex number that means contains two parts, the real part and imaginary part. A equals 0, so if it's the real part equals 0, this one's going to be the pure imaginary part. If B is the equal 0, that means we just have the real part, so it's going to be just the real part. That's what they're going to ask you on the first few questions. If you check on group sign, you're going to select these numbers. So they ask you, number has the form A plus BI. A not equal 0. That means A is not 0, but B equals 0. B equals 0, that means this part, the whole this part is going to be 0. So we just have the real part. So what we're going to choose? We're going to choose a real number. So a real number has the form A plus BI, where A not equal 0, but B equals 0. That means the imaginary part equals 0. So this is called a real number. That means this is just a real number. The second one, number has the form A plus BI, where A not equal 0 and B not equal 0. A not equal 0, and b not equal 0. Check the option. We can't say a real number. We can't say a pure imaginary number, but we can choose an imaginary number. So keep in your mind, when a equals 0, this is the pure imaginary number. Pure imaginary number. This is important, so you're not going to confuse yourself because it's just the imaginary number by itself. Pure imaginary. But if a, b not equal 0, you can say imaginary or complex number. You can say for this one, imaginary or complex number. Or complex. Complex number. Imaginary or complex number. That's what happened, you see, for the second one. A plus bi, where a not equal 0, b not equal 0. So this is imaginary or complex number. The third one, a number has the form a plus bi, where a equals 0 and b not equal 0. A equals 0, that means this part is 0. We just have the bi. That means this is a pure imaginary number. Pure imaginary number. The next part, the imaginary unit I, is defined as imaginary unit I, defined as. So keep this one in your mind. I means square root of -1. So every time you can plug in instead of I, square root of -1. If you remember, we did that before when we have square root of negative number. How are we going to take the square root for a negative number? We're going to take the negative sign out as an I and take the square root for this number is going to be 4i. That means, in fact, square root of -16 is the same thing, square root of -1 times square root of 16. Square root of -1 times square root of 16. -1 is the I, and square root of 16 is 4. So 4i or I4, the same thing. So I is the unit, the square root of -1. That means I squared is going to be -1. This is really important because we're going to use this one a lot. If you have I squared, that means it's -1. So that's what I'm going to plug in here. The imaginary unit I is the square root of -1, and I squared is going to be -1. Not the square root, just -1. That's question 4. The same thing when, next example, they say when A is a positive real number, the of, what we're going to choose, of a negative A is defined as, now check here, the square root of -A. A is a positive number, it's exactly like this example. -16, negative sign is the I. Check here, the I is outside. And this one is a square root. So we're going to choose principal square root. Because A is a positive real number, so we can change the square root of this number. Principal square root. This is, for example, 5. For example, 6. The number A plus BI and A minus BI is called, this is really important. You see the same number but different sign. This one is called complex conjugate or conjugate pairs. So conjugate pairs, how is going to be? The conjugate pairs is A plus BI. The conjugate for this number is going to be A minus BI. The same thing if you have A minus BI, the conjugate for this number is going to be A plus BI. This is really important. And when you multiply the conjugate by itself, the result is going to be A squared plus B squared. So if you multiply, you can check that. Times A minus BI, the result is going to be real number. It's going to be A squared plus B squared. So that's mean equal real number. That's when you multiply conjugate pairs to each other, the result is going to be a real number. So the numbers A plus BI and A minus BI called conjugate pairs. That's it for this example. Find the real numbers A and B such that the question is true. So they just ask you find A and B. Question 7, they ask you to find A and B. Check here. You have A plus BI equal 9 plus 4i. 9 plus 4i. They ask you to just find how much is going to be A and how much B. A is the real part, which is equal 9. And B is going to be equal 4. That's it. That's the solution for this one. You're going to spend 5 seconds. You're just going to type 9 here. And B is 4. Same thing with the second one. A plus BI for question A. A is 19. Because A plus BI is equal 19 minus 5i. That means A equal 19 and B equal, be careful, negative 5. Be careful on the sign. Not 5 is negative 5. So B equal negative 5. B equal negative 5. So I'm going to say A is 19, B is negative 5. That's it for this question. Let's keep going to the next one. Now we have different type. The same way to find the solution, we have to find A and B, because we have A minus 4 and B plus 1i equal 8 plus 7i. Add down the whole. Question 9 is A minus 4 plus B plus 1i equal 8 plus 7i. So check, we need to find the value of A and B. This is the real part equal 8, and here is the imaginary part equal 7. So what I'm going to do, I'm going to say A minus 4, this is A, not 9, minus 4, A minus 4, which is the real part, equals 8. Then I need to solve this one. I'm going to add 4 to the both sides. It's going to be A equal 8 plus 4. So A is going to be equal to 12. So this is the value of A. We're going to do the same thing with the value of B. B plus 1 equals 7. It's B plus 1 going to be equal 7, the imaginary part. We need to solve this one, minus 1 from both sides. So b is going to be 7 minus 1, that's going to be equals 6. So if you plug in 6 here, 6 plus 1 equals 7. If you plug in a 12 here, 12 minus 4 is going to be 8. Now we're going to get 2 equal sides. So A equals 12 and B equals 6. That's it for this. So I'm just going to plug in 8 equal 12 and B equal 6. That's it. Now, question 10. Write the complex number in standard form. Standard form, that's mean A plus BI. So this is the standard form. A plus BI. They ask you in question 10 to write down in the standard form 8 plus square root of negative 25 to the standard form. So we need to write down this as an A plus BI. The same thing, we already know I is the negative square root of negative 1. So check what I'm going to do here. A plus square root of 25 is the square root of 25 times square root of negative 1. You don't have to do this step, but so you can understand what that means. Because when you multiply the same root, you can multiply 25 times negative 1 is going to be negative 25. So now here is the 8 plus square root of 25 is 5. The square root of negative 1 is I. So this is the standard form A plus BI. That's me going to write down here 8 plus 5i. I think with whooper sign, the I, you don't have to write down this I. I think sometimes it's going to be wrong. So in this case, you're going to go to, let's see which one you have to choose. The symbols. Here's the I. I think you can. There's the same I. We're going to check that when we finish. So here's the I. You can just press I on the keyboard. It's going to be the same I, just to make sure. Any questions so far? We're going to do the same thing on 1 minus square root of negative 12. The next one, question 11. We're going to write down this complex number in the standard form. We're going to do exactly the same thing. So 11 is 1 minus square root of negative 12. So we're going to do exactly the same thing. I'm going to say 1 minus square root of 12 times square root of negative. I already know I equal the square root of negative 1. So here is 1 minus square root of 12, and here is the I. Now I have to check square root of 12. I can write down the square root of 12 as 1 minus square root of 4 times 3. And here's the I. That means 1 minus square root of 4 is going to be 2. And we're going to leave the 3 under the root because there is no square root for 3. Here's the I. So this is the standard form, A minus BI. A minus BI. I'm not going to care about the sign here in the middle because here is the red part and this one is the imaginary part. That's it for this question. So I'm just going to write down here 1 minus 2 square root of 3. And here's the thing. If you type the I right away, it's going to be wrong. Because you check the I is under the root. So you have to make sure the I is outside the root, like this. Or you can write down the I here. You can write down the I here in the beginning, or you can write down the I here between the 2 and the root. It's going to be right. Or if you want to write down the I on the end, make sure the I is outside the root to get the right answer. Because if you put it inside the root, it's going to be wrong. The same thing for question 12. If you have any questions, you can ask before I move to the next one. So question 12, square root of -40. We're going to do exactly the same thing. There is no real part here, just the imaginary part. We need to write down this to the standard form. So we're going to do exactly the same thing. Square root of -40 is going to be square root of 40 times square root of -1. The square root of -1 is I. Now we need to find the square root of 40. 40, which number you're going to multiply by other number to get 40? You can say, which number, how are you going to find the root for 40? So how to find the root for the 40? You can say 40 is the square root of 8 times 5, or the square root of 4 times 10. 20 times 2, also 40. 20 times 2. And you need to find the root. We can't use this one. We can't use this one. I'm going to use is the square root of 4 times 10. Because there's square root of 4, which is 2. Square root of 10. Here's the I. Also, I'm going to make sure the I is outside the root. That's how we're going to solve this example. Who has a problem about how to find the root? Type here 2 square root of 10. And outside, I have to make sure the I is outside. Be careful here. So it's going to be 2 square root of 10, I. The same thing with the next example, but it's going to be a little bit harder. And let's check how it's going to be. Write down the complex number in the standard form. This is question 13. And let's check that. It's -6i plus I squared. -6i plus I squared. How are we going to write down this number in the standard form? I already know you have to keep this one in your mind. I is the square root of -1. That means I squared is going to be just -1 by itself. In this case, I'm going to plug in instead of I squared, I'm going to plug in -1. There's a plus or minus. I'm going to keep -6i. Now, this is the real part. This is the imaginary part. I just need to write down in the standard form. So this one is going to be -1 minus 6i. Now, this is the A minus bi. That means A equals -1 and B equals -6. So this is the real part and the imaginary part. So here in this case, we're going to write down -1 minus 6i. That's it for this question. So question 14, we're going to do exactly the same thing. We need to write down this number in standard form. So it's negative 3i squared, negative 3i squared plus 6i. How are we going to write down the question in standard form? So I'm going to check here. I already know I squared equal -1. So I'm going to plug in -1 here. So this one is going to be equal -3, and I squared is -1 plus 6i. As mean in this case, -3 times -1 is going to be 3 plus 6i. So this is the A plus BI. So this is in standard form. So I'm just going to type here 3 plus 6i. That's it for this question. Question 15, perform the operation and write down the result. Now we have addition between two complex numbers. So in this case, we have addition between two complex numbers. We're just going to add the real part and then add the imaginary part. So question 15 is going to be 2 plus I, 2 plus I, plus, that's mean you're going to add with another complex number, 3 plus 7i. So in this case, to add two complex numbers, you're going to add the real part and you're going to add the imaginary part. Be careful, there is 1 here. You're not going to add the I with the I, you're going to say I squared, this is going to be wrong. So you're going to add the real part, 2 plus 3, 2 plus 3. And you're going to add the imaginary part, which is 1 plus 7. And here's the I. You can do it like this, or you can add it right away. You see, this the real part is going to be 5, plus 1 plus 7 is going to be 8. And here's the I. So this is the standard form for this, for the addition of these two complex numbers. I'm going to type here 5 plus 8i. The same thing now, we have minus between two complex numbers. Let's check how we're going to add these two complex numbers. So question 16 is going to be 4 minus I and we will say minus 3 minus I. You have to be careful here because now negative sign for these two numbers. So this one's going to be equal 4 minus I, negative times positive, going to be minus 3, negative times negative, plus I. So it looks like you're going to distribute the sign. Now, this is the real part, this is the real part. So 4 minus 3 is going to be 1. Negative I plus I going to be 0. That means the result is going to be just 1. 1 plus 0i. 1 plus 0i. So here, just going to type 1. And if you type 1 plus 0i, it's going to be I also. Question 16. Question 17, we're going to do exactly the same thing, but now there's no I. So we have to convert these two numbers to a number with the I. Then we can add the result. Question 17 is -5 plus square root of -8 and plus 7 minus square root of -52. Let's check how we're going to solve this example. First of all, simplify the roots. So here is going to be -5 plus square root of -8 is the same thing, the square root of 8 times square root of -1 plus here is the 7 minus square root of 52 times square root of the -1. You can do this step, or you're just gonna go ahead and take the negative sign as an I. So both is going to be right. If you want to do this step, it's going to be fine. Now, next step. Let's keep going. So -5 plus square root of 8 is 4 times 2. And the negative square root of -1 is going to be the I. Plus 7 minus square root of 52. I'm going to say 4 times 13. And the square root of -1 is going to be I. Now this one is going to be equal -5 plus square root of 4 is going to be 2, and the left is square root of 2, and here is the I. Plus here is 7 minus square root of 4 is going to be 2. And here is the square root of 13. Here is the I. Now we need to add these together and write down in the standard form. So how are we going to do that? So we're just going to add the real part. So it's going to be -5 minus 2, so minus plus 7 is going to be 2 plus add this one with this one. Now, if you check these two numbers, we can't add it. Why? Because this is under square root, 2 under square root, and here's 13. So we can't add these two numbers. So what we're going to do, we're going to say this is a plus. I'm just going to add these two numbers to sign, like 2 square root of 2, a plus or minus 2 square root of 13. And here is the I. That means this is the real part, and here is the imaginary part, because the I belongs to this part and this part. So this one, in this case, A plus, and here is the B. The whole thing is the B. And here's I. So this is the standard form for this example. When we write down the solution here is going to be 2 plus, and open 2 parentheses. And I'm going to write down to the first one 2 square root of 2 minus 2 square root of 13. 13, and I'm going to get out from the parentheses, write down the I outside the parentheses. That's it for this question. Question 18. We're going to do exactly the same thing here. Add the real parts and add the imaginary parts. So question 18. we have 25 plus, we have negative 11 plus 17i and plus 13i. So in this case, this sign is positive. That means we're just going to add the real part and the imaginary part. So I'm going to say this is 25 positive times negative. That's mean minus 11 plus 17i plus 13i. Because the positive sign is not going to change the sign inside the parentheses for these two numbers inside the parentheses. Now we're just going to combine the terms. 25 minus 11 is going to be 14, and add these together. So 17 plus 13 is going to be 30. Here's the I. So that means this is the real part, and here is the imaginary part. So we write down this number of the operation in standard form. Just going to say 14 plus 30i. That's it for this question. When you have minus between two complex numbers, you have to distribute the negative sign on the second part, like example 16. Check what we did here. Distribute the negative sign on the second parentheses. And when you have multiplication between two complex numbers. So how are we going to do that? Let's check that. Next example, example 19. Example 19, it says, perform the operation and write down the result in the standard form. So the first number, question 19, is 4 minus 5i. 4 minus 5i times the second one is a 3 minus 2i. 3 minus 2i. So we're going to multiply exactly the same thing. And we're multiplying two numbers, two parentheses. 4 times 3 is going to be 12. Meaning the first one times the first one. Now the first one times the second one. 4 times negative 2i. So 4 times negative 2 is going to be negative 8. That's me minus 8. And here's the I. We're done from distributing the first number on the first parentheses. Now the second one, we're going to distribute negative 5 times the second one. So negative 5 times 3 is going to be negative 15. And here's the I, because negative 5i. Now the last thing, which is the important thing, negative 5 times negative 2. You're going to do mistakes here, so you have to be careful. Negative 5 times negative 2 is going to be positive 10. Positive 10, because negative 5i times negative 2i. When you multiply these two numbers, it's going to be negative 10. Positive 10. Negative times negative positive, 5 times 2, 10. Now I times I is going to be I squared. I squared. Now let's go to the next step. Here's a 12 minus 8i minus 15i plus 10. We already know that I squared is negative 1. That means here is going to be 10 times negative 1. So the next step is going to be 12 minus 8i minus 15i minus 10. Because 10 times 1 is going to be negative 10. Now we're going to combine the terms. This one similar to this one. And here's I, and here's I. So 10 12 minus 10 is going to be 2. And negative 8 minus 15, negative, negative, so it's going to be negative 23i. So this is the standard form for the operation multiplication between two complex numbers. So I'm going to type here 2 minus 23i. Let's go to 20. The same thing, from the operation. We're going to multiply 13 times 1 minus 8i. That means you're just going to distribute this number on the parentheses. So do exactly the same thing. So 13 times 1 is going to be 13 minus 13 times 8 is going to be 104i. You don't have to add down the parentheses. And this is a plus or minus bi. So this is the standard form, because this is a minus bi. So we're just going to type here 13 minus 104i. That's it for this question. The same thing with the 21 and the 22. 21 multiplication between two parentheses, and these two parentheses are complex numbers. So be careful here, because you have root here with the I and root with the I. So this example. Question 21, you have 4 plus square root of 5 I times 4 minus square root of 5i. So we're going to distribute 4 times 4 and 4 times square root of 5i. 4 times 4 is going to be 16. 4 times square root of 5. Just add down 4 square root of 5, and here's the I. Because we can't multiply a number with the root, so just keep it minus 4 square root of 5i. We've done it from the first one. The second one, multiply square root of 5 times 4. So we plus 4 square root of 5i. We can switch the numbers because that's multiplication. We're done from this one. Now we're going to multiply this one times this one. The first thing, positive times negative is going to be negative. Square root of 5 times square root of 5 is going to be 5. So here's the 5. I times I is going to be I squared. So if you look to this part here, minus 4 square root of 5 and plus 4 square root of 5. That means this one, 0 with this one. So just cancel it. So this one is going to be 16 minus 5. I squared is going to be negative 1. So it's going to be 16. Negative 5 times negative 1 is going to be positive 5. And the result is going to be 21. So there is a note, if you remember, we took notes at the beginning. If it says, if you multiply the number with its conjugate, the result is always a real number. That's what we got. We multiply a number with the conjugate, because this is the number, here is the conjugate, there's the different sign. So the result is going to be a real number. This is for this example. I have the quotient in the standard form. Again, before I move on this one, be careful on the question 23. They ask you the conjugate for this number. The conjugate for this number is going to be the number by itself, because you don't have to change the sign, because it's just the real part. So the conjugate, just simplifying the number. Multiply the number by itself, 2 parentheses, and find the result. Question 24. The conjugate, the complex conjugate for this one is just the real part, so it's going to be the same number. And multiply the same number by itself with the conjugate is going to be 15. Question 26, sorry, 25, we need to write down the quotient in the standard form. So these are really important examples. We need to write down the quotient in the standard form. Question 25. So the quotient for the first number is 5 over 7 minus 9i. How are we going to write down this quotient in the standard form? In this case, we need to find the conjugate. This means the conjugate of the bottom part. So I'm going to multiply the whole number by the conjugate. That's mean by 7 plus 9i and 7 plus 9i. So this one is going to be, on the top part is 5 times 7 plus 9i, and on the bottom part is 2 parentheses, 7 minus 9i times 7 plus 9i. You can distribute these 2 parentheses, it's fine, and distribute the 5. So this one is going to be the result. 5 times 7 is going to be 35, plus 5 times 9 plus 45, and here is the I. Let's distribute the bottom part. 7 times 7 is going to be 49. 7 times 9 is going to be plus 63i. Now negative I, the negative 9 times 7 is going to be minus 63i. Negative I, negative 9 times 9 is going to be minus 81. Don't forget there's I. So it's going to be equal. Check here, 63i minus 63i, so it's going to be cancelled. On the top part, you're just going to leave it 35 plus 45i over the bottom part. Here is 49 minus 81 times negative 1, because the I squared is negative 1. So now here is, keep going, 35 on the top plus 45i divided by 49 plus 81. Now, if you look to the bottom part, if you multiply 2 conjugate numbers, the result always is a real number. So the 49 plus 81 is going to be 130. That's mean here is going to be 35 plus 45. Here's the I over 130. we can write down as a 35 divided by 130 plus 45 divided by 130, and here's the I. But you have to check. Can we simplify it? Let's check. Because 130, 100%, you can divide by 5. It's going to be 26. And 35, you can divide by 5 is going to be 7. So this one is going to be 7 over 26. Plus the same thing here. This is 26. And 45 divided by 5 is going to be 9. So the result in standard form, this is A plus B, and here's the I. So we're just going to type here fraction 7 over 26 plus, and the second one is going to be 9 over 26. Now it's going to be I. If you can simplify it more, go ahead and simplify it more. This one you can simplify it more, so that's it. This is example 25. So 26 is going to be 13 over 1 minus I. So we're going to do the same thing. We're going to multiply by the conjugate. So it's going to be 13 over 1 minus I times the conjugate is 1 plus I, 1 plus I. That means here is going to be 13, 1 plus I, and here's the two quantities, 1 minus I, and 1 plus I. This one is going to be equal. 13 times 1 is going to be 13. 13 times I is going to be plus 13I. Now on the bottom part, if you want to distribute, fine. If you want to just say A squared plus B squared, it's going to be fine. Not going to say wrong. So 1 times 1 is going to be 1. 1 times I is going to be plus I. Negative I times 1 is going to be negative I. And negative I times I is going to be negative I. Here, this one is going to be 0. So it's going to be 13 plus 13I divided by 1 minus I squared is negative 1. That's mean here is going to be 13 plus 13I over 1 plus 1. Because negative times negative is positive. So it's going to be 13 plus 13I over 2. And this one is going to be 13 over 2 plus 13 over 2I. That's it for this example. So we're just going to type 13 over 2 plus 13 over 2I. 13 over 2, and the I is here. That's it for this example. 27 is going to be exactly the same thing. 28, exactly the same thing. 29, exactly the same thing. But the conjugate for this number is going to be negative I. I'm going to multiply by negative I. Let's do example 28. So 28 is 9 minus 4I over I. Do not cancel this I with this one. It's going to be wrong. To simplify this one and write down the result in the standard form, multiply by the conjugate. The conjugate for I is negative I. So you're going to multiply 9 minus 4i divided by I, you're going to multiply by negative I and negative I. It's a multiplication. So what I'm going to do, 9 minus 4i times negative I divided by I times negative I. So this one's going to be equal. Now negative I times 9 is going to be negative 9i. Negative times negative, I'm just distributing backward. Negative times negative is going to be positive. 1 times 4 is going to be 4. I times I is going to be I. So everything is divided by I times negative I is going to be negative I. So this one is going to be equal negative 9i plus 4 I squared is negative 1. Divided by negative I squared is going to be negative. Be careful here. The negative is outside. I squared by itself is negative. That's mean in this case, it's going to be negative 9i minus 4 divided by 1. Because negative times negative is going to be positive. We're just going to add down as an a plus bi, which is like negative 4 over 1 minus 9i over 1. It's 1, it's not going to change anything. So the final result is going to be negative 4 minus 9i. You don't have to add down the 1. If you have another number instead of 1, you have to add down as a fraction. So on 28, we're just going to say negative 4 minus 9i. The same thing with the 29, but we're going to multiply by negative 2i. Negative 2i here and negative 2i here.